From Alysia and Ellie, welcome to Composable, a podcast that takes you deep into the tech behind Web3's building blocks.
Every episode, we dive into one key question about how crypto works today and the design space for how it might look in the future.
Composable is an espresso pod, a production of Espresso Systems. All opinions expressed by Composable's hosts and podcast guests are solely their own views. This podcast is for informational purposes only and should not be taken as investment, legal, or technical advice.
Synchronous composability is overrated, according to Vitalik. He tweeted this a few weeks ago. So in this episode, we will unpack what he meant, whether or not we agree or disagree, and what are some alternatives to synchronous composability.
Yeah, sounds perfect.
So I know you have thoughts.
I do have a lot of thoughts on that tweet.
Yeah, so I'm really curious. Do you think synchronous composability is overrated?
So no, I don't.
Okay.
I think that there's a lot of really cool use cases that you can do with it. And I also think that once we have it, people will think of even more new use cases.
Yeah.
And then specifically to Vitalik's point, I agree that there's easier things to implement, but I find that generally the people who are implementing the UX improvements are different from the people who are implementing the infrastructure side anyway. So why not work towards it at the same time? Work towards both goals.
Yeah, I agree. So you disagree. So what are some synchronous composable experiences he's ignoring that is needed?
Yeah, so this is one that I actually run into a lot on Farcaster, is I want to buy an NFT on Farcaster. It's usually listed on Base or something like that. I need to bridge my funds from another chain, then buy it, and then I want to bridge my funds back because I don't actually want to leave dust on Base or some random L3.
Yeah.
And synchronous composability would make that super easy. But you know, now it's kind of hard. To be honest, I have like dust on just all of these different chains that I'm never going to move off. And it's just not a great user experience. So I think this is a key thing where synchronous composability 100% would solve that problem for me.
Yeah, I think that dust point is really strong because in the real world, if you are moving from bank to bank and a bank tells you like, oh no, just leave a few coins here or just leave $1,000 here, like what? Like why can I not move with all of my funds?
Yeah.
And I think that if you had to go to a grocery store and because they're in another bank, you had to then bridge this bank and then leave random money there. Like, that doesn't make sense. So I definitely agree with that. I think in terms of the overall topic of is synchronous composability overrated, my stance is a little bit more nuanced. I do agree with Vitalik in the sense that we can achieve some of the synchronous composable experiences, heavy on the experience, right, by using other solutions, especially things in the UX layer. But I do see value in synchronous composability. So I would say that synchronous composability is definitely something we should strive to accomplish, but it's not the end of the world if we don't have it. But to say it's overrated to me means that there's no need in trying to solve it. And I disagree with that.
Yeah.
And I think from my experience on chain, I definitely love flash loans a lot. I like the concept of being able to create value. You get this loan, you pay it back in one transaction. That's super fun. And you definitely can't do that across chain. And the fact that in Web3, we've created this financial product that doesn't exist in Web2. There's no place that you can go to and say, you don't know my identity, you have no way to guarantee that you're going to get the funds back from me, and then you're going to give me money. And the way that we were able to achieve this in Web3 is because of this synchronous composability, because we had apps speaking together and we had everything completing in one transaction. So now it's to figure out, like, how do we get that same experience across chain? And if that would create new products or just new experiences.
So how would you define synchronous composability?
That's a good question. I think I'll start out defining composability in general. Composability is the ability to interact with applications, multiple applications, as if you're actually interfacing with one. So for example, if I go into Uniswap right now and I try to swap funds, I just talk to the Uniswap UI and I get money back. And what's actually happening in the background is that their contracts communicating with each other. So Uniswap has a bunch of contracts that are communicating, like the pools, and then they're also communicating with the ERC20 contracts of the currencies I'm trying to exchange. So when you talk about synchronous composability, you bring in a time element. For blockchain, if the transaction completes within one block, then you can say this is a synchronous transaction, a synchronous composable transaction. If it completes across many blocks, then that's when you get into the asynchronous composability, and that's how the time differences reveal whether or not it's like synchronous or not.
Yeah, I'd agree with that. I mean, if someone was interested in a more technical definition, I would describe synchronous composability as having the ACID properties, which are what databases strive for. So it's atomicity, isolation, consistency, and durability. And this is a really powerful framework. This is what the database literature has talked about for a really long time. So I think that gives us like a very technical definition compared to asynchronous composability.
Yeah, I like that a lot. And even the fact that we are talking about synchronous versus asynchronous, this is a very cross-chain conversation. Because when we think about a single chain, we don't ever say that. We don't even talk about composability most of the time, except when you're speaking about DeFi Legos. And an example of an asynchronous composable experience on chain, I would say, is a limit order. So as a user, you go to, for example, 1inch's API, you submit an order with an expiration time, and you say that I would like to swap USDC into ETH over the next week. If you can give me at this rate, I'd love that. And in the background, you have other workers working to try to solve that transaction. So someone will see, when I say someone, as in anyone can actually do this. Anyone can run a bot that reads from the 1inch API, sees a list of limit orders, and then fill an order if it's profitable to them. And then the user eventually gets their funds. So that definitely does not happen within one transaction. Like you said, it's not going to necessarily be acid, but at least the intent is there, and the intent can eventually be executed with multiple actors. What do you think is the difference between asynchronous and synchronous composability when we think about a cross-chain experience?
Yes. So I think the main difference is atomicity with asynchronous composability. So you technically could achieve atomicity through some really complicated way, but that you lose that. And having atomic execution of transactions is the exact thing that allows flash loans, like all of these use cases, because you can guarantee that the entire thing succeeds or the entire thing reverts. So this is the big difference between the two.
Okay, I think that makes sense then. So why does composability matter?
Yeah, that's a good question. I think a lot of it is UX and composability. It's like a key part of having chain abstraction. Yeah. Because really, a regular user, they won't want to deal with all of these different L2s. I mean, I am an advanced user and I do not want to deal with all of these different L2s. Yeah. So if we can have really great composability between the chains, then it's a lot easier and a lot safer in terms of risk management to transfer money across chains and have users just see one balance across all of their wallets.
Yeah. And I think it's really refreshing to hear you say that and other people in the space say that. Like, everything we do is really for the user. And I know it's very easy for us to get caught up in very technical conversations, especially as people who work in infrastructure. But we're still thinking about the user. So it's very much valuable to fix problems in the UX side as well as in the infrastructure side. And if we could talk about some of the solutions around, let's start with maybe asynchronous composability. We have that today. So we definitely have solutions which are bridges, message passing, and even intent-based bridges are definitely doing a really good job of doing that across chain. Maybe we should dive into the architecture a little bit, like how they're able to accomplish this.
Yeah, sure. So you have, I think first, like the most simple bridge is just like a native bridge. Yeah. And the way that it works is you take your funds, you lock them in a bridge contract. The rollup has to settle to the L1, which takes like 15 minutes. And then after that settlement, you can then unlock these funds on another L2. Yeah. This is very slow, obviously. So it's not really great. Yeah. But it's safe. Yeah. The other thing you can do is do a relay. So this is where you submit an intent to someone saying, I want to swap between these two chains. Yeah. This person says, okay, I will front you money on the chain that you want, and then I'll take on risk that I'll be able to actually bridge those funds back to this original chain and recoup my money. Yeah. That is much faster, but it comes with a lot more trust assumptions.
Yes. Oh my gosh. Yeah. 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 I think trust assumptions is something I've been personally trying to internalize recently because in the blockchain space, we went from zero trust nothing, trust code. And then now we're like, oh, wait, we have some trust assumptions. Yeah. So in a bridge, if we're dealing with a bridge, for example, and this is like the native bridge or the canonical bridge, we'll have some smart contract on the source chain and destination chain. So let's say this is Arbitrum and Ethereum. By the way, this may not be completely accurate, but let's just give an example. So the user deposits their fund onto the Arbitrum smart contract. They trust that this smart contract is going to do what it says it would, which would bridge it to the other chain. And then we have some player that is able to see that there's a transaction on Arbitrum and maybe either lock the funds or burn the funds. And then these funds will then be minted on the destination chain. And that is definitely a solution that works and it accomplishes the problem of how do I get my funds across chain? But that would happen in multiple transactions, which would make it an asynchronous transaction and an asynchronous composable experience. And the user has to also trust the infrastructure that's responsible for moving the assets or seeing their transaction on one chain and going onto the destination chain. So in that case, it could be the sequencer, for example. We'll spare everyone the details of like sequencers for now. That should be its own episode.
Yeah.
But yeah, so that's with bridges. And I imagine with relayers is similar. The difference is probably that the relayer network is a little bit more decentralized. Anyone can join. Not everyone can just be the sequencer for Arbitrum. But you still have a trust assumption that the smart contracts writing correct code is safe to use. And then the relayers will also be able to interact with it in a way that's secure as well. They can't take your funds and run with it without actually completing your transaction.
Yeah.
So that's the trust assumption there. What's another solution for asynchronous composability?
Another solution, which is maybe not an entirely different solution, but message passing.
Right.
And I view message passing as very similar to asynchronous programming. You have a channel, you pass messages, and this is how it works. I think it's basically the same thing. But message passing is really promising in my opinion. And there's projects out there like Layer 0 does message passing today. I think that message passing by itself does not give you any composability necessarily, but it gives you a really powerful tool on which you can build composability.
Okay.
Yeah.
Okay. That makes sense. And I guess now we have to start thinking about what would be required to make a synchronous composable experience. What needs to happen? So I guess if we can start from the building block or the end goal. The end goal is that somehow, some way we can have all the transactions required for each chain in one block.
Yeah. We
already know that Arbitrum is a whole different network and Optimism is another network, so they can never share blocks per se. I know there's Aglia. Aglia is working on a solution. It's not live yet, or they're in talks and they're publishing articles around it. And I know that Espresso also talks about shared sequences and confirmation layers. And we also have other players who are creating sequences as well, like Astria. Is there a way that could work for synchronous composability, truly?
You mean composability between all of these sequencer projects?
All of the chains.
Oh, all of the chains, yeah. It's classic. In theory, yes, but in practice, no. In theory, yes. In practice, the difficulty is if you want to have composability between chains and you want to be able to enforce certain properties like atomicity, you need the two chains to come to some form of agreement.
Yeah.
And this is definitely doable in the smart contract. It just depends on which chains are willing to agree with other chains.
Yeah.
And this is where a lot of people seem to think the future is clusters of interoperability. Okay. So you will have a cluster of Arbitrum and Arbitrum related chains. They'll all be super composable with each other, but it's really difficult to take that and then move it over to optimisms like the superchain, for example. Right. I really don't want that to be the future. I want the future to have where any rollup can be composable with any other, but I do see that that's a very, very likely scenario just because of the practicalities of getting chains to agree on a single thing.
Yeah. And I think what you mentioned was something that is really key to understanding it, because I used to struggle with the concept of how we can accomplish synchronous composability across chains. And you mentioned some sort of like coordination. And if we think about it right now, when you're interacting with layer 1, we do have some coordination happening. There is some consensus that has to be achieved. So if I am responsible as a validator for publishing the next block, I am determining the order of the transactions within that block and also making sure other things are valid, like the transactions are valid. And then other validators will now agree, like, yes, that is actually a valid block. So we submit it. So we kind of need to have that exact same operation happening where there's some way to coordinate across chains. If I am originating a transaction from my wallet that needs to go to another chain, like there needs to be coordination that like, yes, this is a valid transaction. I do have the funds and I need to know that this will be completed within the next block of each of these other chains somehow simultaneously.
That's the really, really hard part to do.
Yeah. Mm-hmm. Is there anything else that's required besides this level of coordination?
There are a few other things.
Okay.
It depends on what kind of guarantees you want to have. If you want really fast asynchronous composability, which can actually get you really close to the, like you said, the synchronous experience, even if it's not totally synchronous.
Yeah.
That's a little bit easier. But Yeah, for synchronous composability, you definitely need some amount of coordination. And I think that's the most difficult part, actually. Yeah. And then you need some sort of trustless confirmation. So the easiest example would be to use Ethereum. Usually we don't use Ethereum because it's slow, but let's say you have rollup A and rollup B and they want to interact with each other. Well, they're not going to trust each other. So you need to post their data to a place that they both can trust.
Yeah.
And so this is where you need some sort of confirmation layer in there as well. And then finally, shared settlement. Shared settlement is also difficult. But so if you want an atomic transaction, this means that you have to settle each rollup at the exact same time. If they don't settle at the same time, you can just fundamentally not guarantee it'll be atomic. So I'd say those are the three things you need. You need coordination, some sort of trustless confirmation layer that both rollups agree to, and then some sort of a shared settlement system.
Yeah, that makes sense.
Okay, so let's look at a concrete example of an asynchronous atomic swap, which is something that a lot of people would want to do. You're swapping tokens between two chains.
Right.
Atomic swapping is relatively straightforward, but it comes with trade-offs. This began way back in Bitcoin with hash time lock contracts. And the way it works is that user A on chain A will lock their funds and they'll give it a timeout, like 2 days, and says, I can not access these funds unless 2 days has passed. And then the user on the other chain will once they see that Alice has locked her funds, they'll take their funds on chain B and send it to Alice's chain B address. And then once they do that, they get this special key that allows them to claim the funds on chain A so long as they do it before 2 days.
Interesting.
This is the way it works. It has some drawbacks, though. I think the main one is just time. This works for simple transfers, but if you're trying to do cross-chain trading, you can't be waiting necessarily 2 days to have your thing go through. So it's not a great user experience. And obviously, synchronous composability makes this really easy because you can just swap in the same transaction and it's guaranteed to be atomic. So you know the swap will be successful or not.
That is very good. I'm so glad you explained that because that actually clears up a lot for me. So it is possible to have an atomic cross-chain experience, but not possible to have a synchronous atomic cross-chain experience. So it comes back to the whole element of time. Like, how soon do you need this transaction to be complete? Within a block, a couple of blocks, a couple of days. So that definitely helps the user figure out what kind of experience would make sense. So even a developer creating a solution, should they try to use a synchronous composable protocol, which none exists today as far as I'm aware.
Yes, I would say so. You can emulate it by making these really complex things, kind of like what I just described.
Yeah.
But it's just a lot simpler if you have synchronous composability.
Yeah. Okay, I'm really curious. If anyone knows of any synchronous composable protocols right now, please leave a comment. I think intent-based bridging is also something that's becoming very popular. So Cross Protocol recently started speaking about the fact that you can do intent-based bridging with them as well. So I think that's also very exciting for solving for asynchronous composability, but giving the user a feel of synchronous composability. We need to talk about the trade-offs of synchronous versus asynchronous composability.
Oh, yeah, that's kind of a spicy question depending on who you ask. One of the big trade-offs is complexity. So if you have synchronous composability, it creates a really good developer experience, but making it in the infrastructure is a really tough problem. And then it's the opposite with async. You don't have as great of a developer experience, but it's a lot easier on the infrastructure side. I'd say that's one of the big challenges. Also with synchronous composability, you fundamentally need rollups to come to some sort of agreement with each other. And that's difficult to do. Rollups don't necessarily want to agree with other rollups. They don't want to use the same protocols, things like that. So that's really tricky with synchronous composability. And the other thing from a more technical standpoint is that when you have synchronous composability, this means that you can't necessarily do as many things in parallel. For example, a block builder who is building blocks for two chains at once, but they want synchronous composability, essentially they have to execute that as one big block. Now, technically, you can parallelize some of it, but it's not ideal. Versus if you have 100 chains and they each have their own sequencer, each sequencer only needs to do one block, and so it's a lot more efficient. there's trade-offs.
Yeah.
I don't think that synchronous composability is the perfect option for every use case.
Yeah.
And I think asynchronous composability can get you really far.
Yeah.
But I still think synchronous composability is worth it. And in my opinion, it's just such an interesting problem to think about.
I think that's it.
Yeah.
I think that's a lot of it. It's definitely an interesting problem. When I think about the trade-offs between synchronous and asynchronous, I think about the actor. So for example, if I am a relayer in an asynchronous system, there are way more trust assumptions. There's a lot of risk for me. Whereas in a synchronous system, at least if for some reason the transaction, if a relayer is even needed, maybe they're not needed, but at least I know that if the transaction fails, everything fails. So I didn't risk any of my funds to be able to handle this transaction. So definitely there's that. And as well for the user, there are also some trust assumptions there. Across the board, a smart contract can always have smart contract vulnerabilities. So there are always security risk interacting with any blockchain protocol. So that exists across the both of them. But with a synchronous composable protocol, I hope that it would minimize risk for both actors, whether a user or a developer, or even someone who is participating in the system as a builder, because this atomic nature that you get out of the box with a synchronous transaction is definitely attractive to minimize risk. But I do also fear the smart contract vulnerabilities that we have not seen before, because bridges have been the source of
almost the most source of hacks.
Yeah, exactly. The most funds that left this ecosystem was via bridging attacks. Yeah. So I think that's something that always makes people like, ugh. But that's something we have to worry about across all smart contract programming. So that's a whole nother topic to consider. But yeah, I hope that the trust assumptions in a synchronous system would, at least from the user POV, be less. But we definitely have to get like more complicated systems being built. So I think in reality, there might be more.
So my question to everybody else out there is, do you agree with Vitalik and you think synchronous composability is overrated? Or are you a little bit more on our side? I'll include you.
You include me? Okay, cool.
But yeah, you should let us know. I'd love to hear what other people think. I'm not necessarily right that synchronous composability is worth it, but it's a really good discussion topic. It's so interesting to talk about.
Yeah, definitely.
Hey, this is Ellie and Alysia. Thank you for joining us on another episode of Composable. We love hearing from you, so please hit us up on Twitter @ComposablePod, send us feedback, and join the conversation.
Our episodes go live every 2 weeks at 7 a.m. Eastern Time, so make sure you like and subscribe so you never miss an update, and you can even enjoy it with your morning coffee. Share it with your friends and fellow builders.
We'll see you next time on Composable.